In this lesson, I'll show you how to use implicit differentiation. This is part 4. The question reads, find dy over dx given the function sine xy is equal to x squared y. Let's start on the left side. We have sine xy. The derivative of sine is cosine. So instead of this sine, we can write down cosine xy. And now what we do is we take the derivative of this and multiply it to cosine xy. To find the derivative of xy, we need to use the product rule, and that's shown right here. And with the product rule, you leave x the way it is and multiply it to the derivative of y. And then you leave y the way it is and multiply it to the derivative of x. So let's leave x the way it is. And the derivative of y with respect to x is dy over dx. Plus, now the derivative of x is 1, and we leave y the way it is. I'm going to write that down into here. That takes care of the left side. Now on the right side, again, we'll need to use the product rule. So doing the same thing as before, I'll leave this the way it is. Find the derivative of y, which is dy over dx, with respect to x, of course. Plus, the derivative of x squared is 2x. Leave y the way it is. This will be on the right side. Now that I've cleaned everything up, I need to collect like terms. In fact, I need to isolate for dy over dx. And to do that, I'll need to expand the left side first, because I need to liberate this dy over dx. If I expand the left side, I end up with cosine xy times this expression. I'll put the x at the front, dy over dx. And multiplying cosine xy with y, that gives me y times cosine xy. The right side stays the way it is. Now that we have that, I can finally collect like terms. So this term and this term are alike, and these two terms are alike. So I'll bring this term and this term to one side, and I'll bring these two terms on the other. This gives us x cosine xy dy over dx. Bringing that term over makes it minus x squared dy over dx. I will soon factor out dy over dx is equal to 2xy. Bringing that over makes this negative cosine xy. I can factor out the dy over dx on the left side, leaving me with these two terms within the brackets. The right side stays the way it is. Now, you will divide both sides by this expression so that we've isolated for dy over dx, leaving us with dy over dx is equal to this divided by that. And there you have it. What you see here represents the solution to our question.